Hello there, Geometry. Welcome to Chapter 9. The first lesson has some review, but also some new tidbits to it, covering the Pythagorean Theorem. Chapter 9 is going to deal a lot with triangles, right triangles specifically. And we actually get to start a little bit of trigonometry in this chapter. So this is probably one of my favorite ones to do. Trigonometry allows you to solve problems where you don't know two of the sides of a right triangle, and it's used quite a bit in some of the engineering and mathematics in buildings and constructions and stuff like that. So that won't happen until lesson 4 though. So lesson 1, Pythagorean Theorem. It starts off with how can you prove the Pythagorean Theorem, and feel free to kind of read through that and try some of those if you want to. We are very familiar with that theorem already. We've seen it throughout this textbook. You saw it in middle school a lot. One of the new things that we're going to have here is what we refer to as a Pythagorean triple. Pythagorean triple. Okay? And what a Pythagorean triple is, it's 3 integers. Think of those as whole numbers. Okay? 2, 3, no fractions. It can't be a fraction. 3 integers, they can be whole numbers. We're not going to use negatives when we're deal length. Whose side lengths, so if you represent these as side lengths, will always form a right triangle. Okay, so a Pythagorean triple of 3 integers, they have to be whole numbers whose side lengths will always form a right triangle. Now we know there's infinite number of right triangles, but these are going to be ones that are always going to form a right triangle. So these are some of the common ones down here. These are the base ones. These are your base values. A 3, a 4, and a 5. That, if you have a leg of 3, a leg of 4, and a leg of 5, that will always form a right triangle. Same with 5, 12, 13, 8, 15, 17, 7, 24, 25, 9, 40, 41 is another common one. There are a ton of these as well. There's even formulas to how to find them. If you can remember some of these basic ones, it's going to make some of the math a lot easier, because these show up quite a bit, and they keep showing up. So if you recognize, hey, the legs are 3 and 4, the third length has to be 5. Any multiple of these will also work. So you notice if I take these times 2, I get 6, 8, and 10. That will also be a triple. Okay, 9, 12, 15, that would be times 3. So they say 3x, 4x, and 5x. Okay, all of those can be a Pythagorean triple, which means they will work in the Pythagorean Theorem, which we have right here. Okay, so to show you that, here I have this triangle. I have a side length of 3, a side length of 4. I measured across on the hypotenuse, and it was 5. So 3, 4, 5 will always form a right triangle. I can go down to 6 on that one, 8 on that one, and you see the 6, 8, 10. Okay, so 6 squared plus 8 squared, the square root of that is going to be 10. 8, 15, 17. I'm probably going to have to move it up here a little bit. Let's go 8. There's 8. Let's go to 15. See, 8, 15, 17 works. You change that number, then you start getting into the decimals. Okay, so those are referred to as Pythagorean triples. 3 numbers that will work in the Pythagorean Theorem, and they have to be whole numbers. So we have the Pythagorean Theorem, which we've seen before. Remember these two, they're referred to as the legs, and it's the smaller 2 numbers. Okay, so A and B form the right angle, they're called the legs. C is called the hypotenuse, and it is the longest side. Okay, it is the hypotenuse, and it is the longest side. I think there's something else I was going to cover in this section right here. I'm not remembering it right now, though. Okay, so a squared plus b squared equals c squared. That's what it was. So if you need the length of the hypotenuse, if you need the longest side, that is going to be c. And if you solve for c, you have to take the square root of both sides. So c equals the square root of a squared plus b squared. Make sure a squared plus b squared gets done before you do the square root. Okay, so a squared plus b squared. If you're looking for a leg, that can be a or b, it doesn't matter. Then you would have to take the longest side, subtracting the other side. So I would say it's c squared minus b squared. It has to be c squared first. So the hypotenuse has to go first in that subtraction. The order in which you add for the hypotenuse does not matter. The order in which you subtract does matter. Okay, you won't get a square root. That makes sense if you have a negative there. So write those two formulas down, whether you're looking for a hypotenuse or looking for a leg. Okay. Question here. Do the side lengths of 15, 20, and 25 form a right triangle? Okay, do the side lengths of 15, 20, and 25 form a right triangle? So we look at these three here, and we know that 3, 4, 5 is a base value, and if I take each of these divided by 5, we would know that yes, it does, because 15 divided by 5 equals 3, 20 divided by 5 equals 4, and 25 divided by 5 equals 5. So there's your 3, 4, 5 base value. So yes, 15, 20, 25 is a multiple of a 3, 4, 5 triangle. So that's called just a 3, 4, 5 triangle. Okay, 3 and 4 are the legs, 5 will always be the hypotenuse. Okay, the converse of Pythagorean theorem. This just says what we were just looking at. The questions that they're going to ask here, it's going to work backwards. They're going to give you three values, and they want you to check, do they form a right triangle? So let's pick some numbers that are not Pythagorean triples. Do the side lengths of 6, 10, and, okay, 6 plus 10 is 16, so it has to be less than 16. Let's go 13.5. Make up a number. Form a right triangle. Okay, so what we do in this case is we ask, does a squared plus b squared equal c squared? Okay, c has to be the longest side, so this has to be c. A and b can be either one of these. So does a squared plus b squared equal c squared? So does 6 squared plus 10 squared equal 13.5 squared? We should be able to recognize, hey, 13.5 squared is going to be a decimal. It's not going to be working out too well. So we get 36 plus 100, that's 136. 13.5 squared, we get 182.25. No, not a right triangle. Okay, we're going to use the same process in the Pythagorean inequalities theorem, and that actually tells us, okay, it's not a right triangle. Is it acute or is it obtuse? So these formulas here say, okay, if c squared is less than a squared plus b squared, then triangle ABC is acute. So if this squared is less than these two, it has to be an acute angle. Okay, it's an acute triangle. If c squared is greater than it, then it's going to be an obtuse triangle. And again, c has to be the length of the longest side. It's written right here. c is the length of the longest side. The following statements are true. So back in our example here, we had c squared being greater than 136, c squared being greater than the 2. So we fit underneath this one. So we would say this is actually an obtuse triangle. Okay, because it's greater. If it's greater, then it's obtuse. If it's less, then it's acute. So let's go 5, 6, and 7. 5, 6, and 7. What kind of triangles are formed by 5, 6, and 7? So our C value is 7. So C equals 7. So hang on. Let's compare 7 squared compared to 5 squared plus 6 squared. So we take 5 squared plus 6 squared, that's 49. 5 squared is 25 plus 36. So 49, 25 plus 46 is 61. 49 is less than 61. So c squared is less than a squared plus b squared. So that fits this category right here. We know we have an acute triangle. Okay, if it's less than, it's acute. If it's greater than, it's obtuse. If it's equal, then it's right. Okay, find the value of x. The assignment is going to go a step further, and they're going to say find the exact value of x, then tell whether the side lengths form a Pythagorean triple. If they do not form a Pythagorean triple, then you can't have decimals and have Pythagorean triple. So that's how you know whether it is forming one or not, if there's decimals or not. Okay, so we've seen a lot of these questions. We've done these before. The thing here is going to be exact. Okay, we're looking here for our c value. This is the hypotenuse. So we can use our formula. Oh, that's what I was looking for, that sheet. Okay, we're looking for the hypotenuse. I'm just writing that, I guess. So c is going to be the square root of a squared plus b squared. So it doesn't matter which one's a and which one's b. If you recognize a triple, we can go with that. So x is going to equal the square root of 81 squared plus 108 squared. Handy dandy calculator. Square root. One of these, you can just type it in right as it is. 81 squared plus 108 squared. That gives us 105. So x equals 105. That is a whole number. So it is a triple. So 81, 108, 135 forms a Pythagorean triple. Okay, now on number 2, I'll give you a heads up. That's where these Cassius are going to be very, very helpful for you. We're looking for a leg. So when we have a leg, we have to do a subtraction problem. So c squared minus b squared. So here you take the longer side. So x is going to be the square root. The longer side has to go first. So 8 squared minus 4 squared. 8 squared minus 4 squared. So x is square root, that's 64 minus 32. Sorry, 64 minus 16. That's going to be the square root of 48. I believe you can type your answer in like that, square root of 48. Again, if you're using this, we have 8 squared minus 4 squared. It gives you 4 root 3. Okay, the decimal there is about 6.928. If they want an exact answer, it has to be given in radical form. Okay, so it has to be a radical. I believe you can put the square root of 48, or you can put 4 root 3. That is in simplest form. Remember how we do simplest form are the factor trees. So two numbers that go to 48 are 2 and 24. 24 is 2 and 12. 12 is 2 and 6. 6 is 2 and 3. So we have a pair of 2's, and every time you have a pair, that number gets to go outside. 2 times 2, and then we have a square root of 3 left over. So 4 root 3 is how we got that, okay, without a calculator. So 4 root 3, and 8. This is an irrational number, so this is not a triple. Okay, those are the two formulas you're using through this. Calculator makes it real easy for you. Okay, 15 and 20, we're looking for the hypotenuse. So x is the square root of 15 squared plus 20 squared. Hopefully you recognize this. 15, 20. The hypotenuse has to be 25. Okay, again, if you need to check it, 15 squared plus 20 squared. 25. Boom. So this is a triple. Okay, let's crank these out here. 6 and 10. We're looking for the hypotenuse, so we're going to add them together. So square root of 6 squared plus 10 squared. That's the square root of 36 plus 100. So square root of 136. That's not a perfect square. So let's check that here. Square root of 136. See if we can simplify it. 2 root 34. So if you factor it down, you'll have a pair of 2's. So 2 root 34, and that is not a triple. Okay. But these answers, when they want exact answers, you have to put it in a square root form. 77, 55, hypotenuse, long side. So x is going to equal the square root of 77 squared minus 55 squared. Square root of 77 squared minus 55 squared. 22 root 6. We have a square root in our answer, not a triple. So x equals 22 times the square root of 6. If you measure it out, it's almost 54, if it was inches or feet or meters or whatever it is, almost 54. But that's the exact answer, not a triple. We've had two not a triples in a row. I'm going to guess the third one here is going to be a triple. 48, 90, so x is the square root. Those are the legs. 48 squared plus 90 squared. There we go, that we can see that. 48 squared plus 90 squared. 102, 102. We got a triple. We got ourselves a triple. Okay, number 7. From school, you biked 1.2 miles due south, then 0.5 miles due east to your house. If you had biked home on the street that runs directly diagonal from your school to your house, how many fewer miles would you have biked? Okay, this is a good question for Rambo runs if you're in cross country. Okay, was it better to cut across the field or run around? So if you're biking, here you are, you're going 1.2 miles due south, so 1.2 miles, and then a half a mile east, so 0.5. So there's our triangle. Okay, drawing out, sketching it out always helps. So we have a right triangle because it's south and east. 1.2 and 0.5, we want to find x right there. So x is going to be the square root of 1.2 squared plus 0.5 squared. Square root of 1.2 squared plus 0.5 squared. 13 over 10, which is 1.3. So we have some form of Pythagorean triple there. 5, I don't know if you see the 5, the 12, and the 13. 0.5, 1.2, it's just tenths, just divided by 10 there. So your factor, when they said 5x, 12x, and 13x, your factor here was just 1/10. They multiplied those by 1/10. So 0.5, 1.2, 1.3. So that equals 1.3. So that length right there is 1.3. You traveled 1.7 miles. Okay, 1.2 plus 0.5 is 1.7. How many fewer miles would you have biked if you would have done this? So if I take 1.7 minus 1.3, 7 minus 3, I get 0.4. So by taking the south and east roads, you went 4/10 of a mile longer than if you would have just taken the diagonal road. Okay, these questions. Verify that the segment length form a triangle. Is the triangle acute, right, or obtuse? Okay. This first part, verify the sum of the two smaller sides must be greater than the third side. The sum of the two smaller sides must be greater than the third side. So that's the verify part there. Just make sure it forms a triangle. Okay, remember the triangle inequality, the two sides have to be greater than that third side. So if I have 90 plus 216, that is 306, and that's greater than 234. So it does form a triangle. Is the triangle acute, right, or obtuse? So this is my C value right here. 234 is my C value. So we're going to check it with using the Pythagorean ratios. So 234 squared, compare that to 90 squared plus 216 squared. So 234 squared, 54,756. And then we need to do 90 squared plus 216 squared, 54,756. So they're equal. That makes it a right triangle. Okay, they're equal, so it makes it a right. If c squared is less than, remember that's acute. If it's greater than, it's obtuse. Okay, we have the square root here, 1, 1, and root 3. Square root of 3 as a decimal is 1.73. 1.73. So 1 plus 1, this is our C value. 1 plus 1 is 2, and 2 is greater than 1.73. So this is a triangle. Okay? So I have to take square root of 3 squared, and I'm going to compare that to 1 squared plus 1 squared. 1 squared plus 1 squared. C squared compared to a squared plus b squared. C has to be the longest one. So the square root of 3 squared is just the number 3. Square root of 3 squared. The square cancels off the square root. 1 squared plus 1 squared is 2. So 3 is greater than 2, making this an obtuse triangle. It is greater than 2. The final ones you're going to have, you have some questions here. Finding area. Find the area of an isosceles triangle. Area for any triangle is 1/2 of your base times your height. So they're giving us an isosceles triangle. The height, remember, is a perpendicular bisector of the base. So if this is 18 and this is 10 down here, that makes this side 5. So when you're looking for your height is going to be the square root. You see the right triangle there? The height is the square root of 18 squared minus 5 squared. So 18 squared minus 5 squared. Square root of 229. Okay, that's a unique number there. 299. Square root of 299. So when they want these answers, if they wanted an exact, we're going to have to keep square roots. If they want an approximation, then when we're done, we're going to round it. Okay, about 17.3 for that height. So our area is 1/2 of our base. Our base is back to this whole number here. So 1/2 of 10 times our height, 1/2 base times height, 1/2 base times height. Our height is the square root of 299. So if they want an exact answer, you can take 1/2 of 10, 1/2 times 10 is 5, and you would just say it's 5 times the square root of 299. That's the simplest form for an exact answer. If they want you to round it, then you have to take this. Well, you're going to take that answer times 5. There's a 5 root 299. It's 86. See, there it is. About 86.5. Let's say we have square inches. Let's make these inches. Okay, so 86.5 inches. Okay, so working through this again. You have an isosceles triangle. This is a perpendicular bisector, so you cut half of this out. That's going to be 16. Your height is going to be the square root of the leg, 20 squared, minus half the base, 16 squared. Notice the 16 and the 20. So if I do the square root of 20 squared minus 16 squared, I get 12. That's a Pythagorean triple. Okay, 12, 16, 20. Multiple of 3, 4, 5. So our area is 1/2 base times height. Okay, see if you can figure this out. 1/2. The base, what number do you put for the base? You go back to the big 32. Big 32. Times your height, which is 12. So 1/2 of 32 times 12, that's 16 times 12. And we get 192 square feet, whatever it is there. Final questions. Reminder of rationalizing the denominator. If we did the maintaining your skills, we did this, but when you have a square root in the bottom, they say to rationalize the denominator has an irrational number. Just take top and bottom times that square root. Okay, you're multiplying by 1. Anything over itself equals 1. This becomes 4 root 2. A square root times itself is the number on the inside, so 4 root 2 over 2. Now you can reduce that, you'd get 2 root 2. So 4 divided by 2 root in simplest form is referred to as 2 root 2. 5 over square root of 3, take square root of 3 over square root of 3, you get 5 root 3 over 3. That would stay like that because the 5 and the 3 are both outside, you can't reduce them. Same sort of thing here, 8 over the square root of 5, take top and bottom times the square root of 5. You get 8 root 5 over 5. That would be simplest proper form with that. So that's coming up here in lesson 2. We have some special right triangles that have some common ratios. If we can get those nailed down, that makes a lot of things very quick and easier for us as we finish up this course. So good work, and we'll see you in class.